Hi, Arnaud.
Hi, Sadek.
So last time we did the video, we talked about the support of GraphQL in Prismic.
Yeah.
And I thought of today making a video to talk about the progress on that and several problems and things that we had to tackle to get to the next release.
Yeah,
actually, of
exactly.
GraphQL.
So the last time we talked about GraphQuery, which was the first step to reach the native implementation of GraphQL. And today we want to talk about the actual implementation, which is going to be released very soon.
So yeah, this week we are going to release an alpha.
Yeah.
And we are very excited to see like how the community will react to that. And we while doing that, while working on GraphQL, well, first we tried to kind of understand from the community what are the clients of GraphQL that are used by the mostly used in the community.
Yeah.
And it seems that
Apollo
is
one of the famous. Yeah.
And because that was important for us to understand like what to support and what not to support. So the other thing that we ran into different issues, and one of them is caching, right?
Yeah, exactly. It's one of the biggest issue in GraphQL because it's not really conventional. Because the default implementation of GraphQL is based on post request. So I don't know. Yeah, if you want to explain.
So the main thing is that mostly REST APIs are there are different verbs that are used. Like there is get, post, put, delete, head, and others custom. And the thing is, these are in the specification and they are understood, by everyone, basically. Browsers, reverse proxies, CDNs, everyone understands the semantics and what they mean. So basically, if a browser sees or reverse proxy or a CDN sees a GET request, they know that it's not doing an action behind the scene because that's the semantics. Which means that if the specification and if the header allows that, then it will cache it. Yeah. Basically, it will fetch it from a local storage instead of going back to the server, the original servers, and getting it from there. And that's extremely efficient if you do it right.
Yeah.
And the fact that the GraphQL chose post, it will make everything go into the same tunnel, the post tunnel, and that will mean that it's very hard to tell the kind of browsers and all these intermediate servers that yes, you can cache this one.
Yeah.
And what do you think? Like we talked about this offline, and you told me that you explained to me why some of the reasons why people behind GraphQL chose to do it like the post way.
Yeah, there are multiple reasons. For example, you have mutations in GraphQL to write some content, but you have also the limitation of the URL, the length of a URL. For example, in a browser like IE or in a CDN like CloudFront, you have a limitation of 8,000 characters, I guess. It's 8,000. And you have as a browser like Chrome or Mozilla, you don't have this kind of limitation because it's like 60,000, I guess. So it's not a very big limitation.
Yeah.
But if you face this limitation, for example, in IE, it's going to be your clients. And
so first, let's go for the first idea. Is that since GraphQL a lot of times will be implemented in the browser, it means whenever you do a request, it's going through. If it gets through a GET request, then you will have to pass the query in the URL.
Exactly.
And the URL has limitations.
Exactly. Yeah.
And you were telling the second problem about that. Not only that it's limited.
But
worst
you won't
thing about
see it during the development. Yeah,
you won't see it. Maybe you're
maybe you're using Chrome or Mozilla, for example. So you won't see the limitation, but your user will see it and won't be able to just see your website
because it will be broken on his side without even getting to your server.
You won't even have like an error or something. You won't even see it, and you won't be able to.
And we try to dig further to see like, can't you send a kind of a body in the GET request?
We tried that because like Elastic, for example, they use this kind of specific protocol. They use GET request, but they put the content in the body of the GET request. But there's nothing about it in the specification.
And the clients don't support it. That's the most important thing because you want to use the tooling. That the most interesting thing about GraphQL is that to use the tooling that.
For example, if you make a request with fetch won't allow to put something in the body of a GET request.
Right. That's in JavaScript, you mean?
Yeah, in JavaScript.
Of course. And so we end up using get anyway.
Yeah, we end up using get anyway. You have some implementation like APQ, which is like a layer on top of Apollo server, which fix it by you can basically you make a post request with your GraphQL query, and it will send you back an ID, so you can put it in the request, in the get request, and get the result from it. So you won't be limited by the URL length.
So it seems a bit hacky, but I got my way of imagining it like as a model. So there is, it seems like you're asking to create a resource, like you create a service, an endpoint
like
for
an
you.
endpoint, yeah.
Yeah, and you have that ID, and later times then you will only talk about that endpoint using the ID.
Yeah.
And the fact that this limitation of the number of characters is important, because GraphQL doesn't only talk, so it's not only talking about the filters that you want to apply to the data, but also about the relations that you want to fetch, and that's why it gets quite big sometimes, because you actually are selecting the fields and the nested field that you want to get.
But you have other way to limit the queries. For example, if you consider each field to be a bit heavy, you can limit it on the implementation on the server side and say, okay, this relation is going to be a bit big. If you have many of them, we will just stop the request and return an error, for example.
Right. But
based
that's
on the
server, not
on the
on
depth.
client. So it doesn't.
It's your own implementation. Yeah.
So it doesn't solve the problem of limitation of a browser.
No.
But anyway, it seems Chrome and Firefox is not a problem, and you have that method of posting so that you get that idea and get your own endpoint. So there's another thing that we talked about and we had to find solution for is pagination, right?
Yeah, pagination, exactly.
So can you explain a bit the problem as you explained it to me?
Okay, so basically we have two different tools, which are Relay and Apollo. And they have different way of handling pagination. For example, Relay have a very, very clear specification about it, and you have to follow this specification if you want to be able to use Relay. And Apollo, you can do pretty much whatever you want. You can have your own implementation of the pagination.
So basically implementing pagination, it means how do I pass these arguments?
Exactly. Like page or page size or this kind of
and
argument.
get the information about which page I'm at, so I know how to page it.
Exactly. That's the issue.
How many results, all these kind of things, right?
Yeah.
So Relay has a very strict clear specification about pagination.
Basically, if you don't follow their specification, you won't be able to
use Relay.
Yeah.
And who else implements the pagination of Relay? You told me GitHub, right?
GitHub yeah. For example, GitHub has the same implementation, and it allows them to have a compatibility for Apollo and for Relay. So
Apollo that wouldn't care anyway, so it will work anyway on Apollo.
Yeah.
But that adds some in the JSON structure. It will add a level of nesting. You'll have nodes.
Yeah, you have a notion of edges and nodes. Edges, it's like pages, and nodes like each element in the page. So you have,
and they have that so that you can store the metadata somewhere, right?
Exactly. Yeah.
Okay.
That's the reason.
Okay, that's very clear. So this week the alpha.
Yeah, I hope you will be many to join the alpha.
Yeah, right. And then we will see the feedback and we get.
And maybe we'll make a new video to answer the questions.
And if there are any, of course.
Yeah.
Well, thank you, Arnaud.
Thank you, Sadek.